Poisson's ratio, it is denoted by the letter symbol mu. It is defined as the ratio of lateral strain to the longitudinal strain. It is a ratio between the quantities of the same dimension. So Poisson's ratio has no unit and no dimension. It's a dimensionless number. Now we are going to learn about the new term called Poisson ratio. The Poisson ratio is denoted by the letter mu. This ratio is mainly used to check or to note down the elastic properties of the materials. Here, look at the wire. So in this copper wire, the diameter of the wire is 10 millimeter. The length of the wire is 10 centimeter. So this is not yet stretched. So before stretching, the diameter is capital D and the length of the wire is L, capital L. After applying the deforming force on either side, what happens? The length of the copper wire is increased. That is called, what is this? When it is stretched, its length is increased means it is subjected for longitudinal strain. Are you clear? Longitudinal strain. That is, length is increased. Along its length, the length is increased. Can you understand? So when the length is increased, when deformation occur in this particular direction, another deformation also created in the middle. Are you clear? Here one more deformation is created. That one causes the compression. Here elongation takes place. Here compression takes place. When elongation takes place, length is increased. When compression takes place, diameter is decreased. So what is the new length now? Original length is 10 centimeter. Apart from that, one more additional length is increased. That is small l. So L plus L is equal to 11. Therefore, increase in length is how much? 1 centimeter. Increase in length is 1 centimeter. Now, when the length is increased, in the middle there is a compression. That one causes the decrease in the diameter. Understood? How to calculate the decrease in diameter? Initially 10 millimeter is the diameter. Now the new diameter can be taken as D dash. Now the new diameter is 10 millimeter. So how to calculate the decrease in diameter? Small d, decrease in diameter small d is equal to capital D minus D dash. Therefore 10 millimeter minus 9 millimeter is equal to 1 millimeter. That one gives you the decrease in diameter. Now by using this increase in length, by using this decrease in length, we have to find out which one? Poisson ratio. The formula to calculate the Poisson ratio is mu is equal to Poisson ratio. Poisson ratio mu is equal to, the formula is lateral strain, lateral strain, lateral strain. Lateral strain means which one? This strain is called lateral strain. Lateral strain is due to compression. Whole divided by longitudinal strain. Longitudinal strain. So two things to be calculated. One is lateral strain and the longitudinal strain. Are you clear? In between these two, we have to find the ratio. Understood? Lateral strain to be divided by longitudinal strain. If you calculate the ratio between these two, you will get the Poisson ratio mu. So what is the formula to calculate the strain? In general, strain can be calculated by the fundamental formula called change in dimension, change in the size divided by original size. Lateral strain can be calculated by, here, that compression to be noted. Lateral strain is created due to compression. Lateral strain can be calculated by the formula. What is this? Decrease in diameter divided by original diameter. Decrease in diameter divided by original diameter, that one gives you lateral strain. Whole divided by longitudinal strain. Here lengthwise some variation is created now. There how to calculate? Change in length divided by original length. Change in length is how much? Small l. Are you clear? Original length is how much? Capital L. Are you clear? Substitute both. Now we can alter the formula. How will you alter the formula? D by D into L by L. So this is a formula to calculate the mu, Poisson ratio. It's a ratio. Are you clear? So in the tabular column, the Poisson's ratio of various metals are given. The rubber is highly elastic. Its Poisson's ratio value is 0.499. Cork is the very toughest material. Therefore, its Poisson's ratio is 0. In the case of cork, though the stress is applied, the change in the length and the change in the diameter is not seen. Therefore, its value is 0.